All right, hey guys, we're still in section 2.6. We're just going to go over a few different types of equations. So, how do we solve a polynomial equation? And if you recall from a few sections ago, a polynomial is just non-negative powers of x added together with coefficients in front of the x terms. And so you can see in this polynomial, we have an x to the third power, and we don't really know how to solve polynomials that aren't quadratics, x squared plus 5x plus 6. But what you can recall is that originally when we had these quadratic equations and we would try and factor them, right, we would look for p and q such that it multiplies to a times c, which in this case is 6, and add to the b term, which in this case is 5. And so once you figured out what those numbers are, which in this case are 3 and 2, we could split 5x into 3x and 2x, and then we would factor by grouping, right? We group the first pair of terms together, the second pair of terms together, and then factor out what each pair had in common. So in this case, the x squared plus 3x has x in common, so we factor that out here. And the 2x plus 6 has the 2 in common, so we factor that out there. And our factored form is the binomial that matches, and then the other binomial is what's left on the outside, right? Okay. So when you see a polynomial in this form, you'll notice that it has 4 terms, just like our quadratic does after we figure out what p and q are. So essentially, you're going to solve these in the exact same manner. You're going to group stuff off. So what I recommend doing is listing the terms from the largest power in descending order. So this one's already done for us, but you're going to group them in pairs of 2 again. Put a plus in the middle. And so we're just going to factor out what each pair of terms has in common. So x cubed and x squared, they both share x squared. Well, what's left over? Well, x squared times x is x to the third. X squared times 1 is x squared. And what can we factor out of the second term? Well, they both have negative 9 in common. And so what's left over? Well, we have an x and then a positive 1. And you can see we're kind of in the same situation we were in here. Our binomial matches, so that's one of our factors. And what's left on the outside is our other factor. And so what we have is x squared minus 9. And so from here, you might recognize that this is a difference of squares, which it is. And so x squared minus 9 factors into x plus 3, x minus 3. And so since all these things are being multiplied, we can use the zero product property and set all of these equal to 0 and solve to figure out what values solve our polynomial equation. But it's basically the same steps that you've been doing in the last section on how to solve a quadratic equation. So this tells us x is equal to 3 when we add 3 to both sides. This tells us x is equal to negative 3 when we subtract 3. And when we subtract 1, we get x is equal to negative 1. So that's how you solve a polynomial equation. Basically, it hinges on the idea that you have an even number of terms and you're going to factor out what's in common. And hopefully you'll get a binomial that matches. And set every binomial you have, set equal to 0. And so our solution here is x equals negative 1, x equals negative 3, and x equals positive 1. Cool. Okay. Solving radical equations. So in this example, we have the square root of 3x plus 18 equals x. And remember that our general goal is to get powers of 1 of x by itself. And so the problem we have right now is that this x is stuck in the root. And because we're working with equations, we can use the fact that squares and square roots are kind of algebraic inverses of each other. So all we really have to do is square this side. And if we square that side, we have to square this side. And what do we get? Well, the square of a square root is just what's on the inside itself. And so we get 3x plus 18, and x squared is x squared. And what you'll notice is this kind of looks like a quadratic. So you're going to isolate x squared, or sorry, you're going to get a 0 on one side, so you can use the zero product property. And so we're going to subtract 3x minus 18 on both sides. And that's going to give us x squared minus 3x plus 18 is equal to 0. And so now we're looking for two numbers that multiply to 18 and add to negative 3. And if you can factor by hand, that's what you would do here. But if you can't, you would use the completing the square method to solve this. And this should be minus 18. Excuse me. And so, luckily for us, p times q equals negative 18. P plus q equals negative 3. Well, negative 6 times 3 is negative 18, and negative 6 plus 3 is equal to negative 3. So this one, luckily for us, is factorable by hand, so we don't have to complete the square on it. But just know that that is something that you'll be asked to do at some point. So this one will factor into x minus 6, x plus 3. We use the zero product property, and that tells us x is equal to 6, x is equal to negative 3. And that's how you solve a radical equation. Essentially, you're going to keep squaring until you no longer have x's inside of roots anymore. Cool. There are a few more complicated ones that you'll see in the homework that may require you to square both sides more than once. But if you have any questions on those problems, you can ask me in office hours or in the Discord. All right. So another type of equations that we're going to learn how to solve in this section is absolute value equations. So recall that absolute value is basically a measurement of distance. How far is a number from 0? So the absolute value of 8 here is 8, and the absolute value of negative 8 is also 8 because they're both 8 units away from 0, right? Cool. And so when you have an equation, the absolute value of x equals 8, how would you solve it? Well, the absolute value of x equals 8 tells you that x, the number inside of here, could have been 8, right, from above, or it could have been negative 8. Either way, it's going to be equal to 8. So that means x could have been 8, or it could have been negative 8. So when you have absolute value equations, you have possibly two solutions. And so the absolute value of x equals 8 is x is plus or minus 8, or just like we said before, x is equal to 8, or x is equal to negative 8. So let's come up with an example here, and we have one waiting for us. The absolute value of 4x plus 4 is equal to 12. So the idea here is that, and I can make this a little more complicated. Let's do minus 4. Let's do minus 12 is equal to 28. Cool. So we have this absolute value equation. So how are we going to solve these? Well, the idea is that we want to get the absolute value by itself first. So we're going to get all the numbers on the other side. And so we can do that by adding 12 to both sides. And so we're going to get the absolute value of 4x plus 4 is equal to 30. And now we're in the same situation that we were in our examples here. What we're going to do is we're going to say the absolute value drops off, and you get 4x plus 4 is equal to positive 30. And you're going to come up with another equation, 4x plus 4 is equal to negative 30. And so you essentially have two linear equations to solve. So let's go ahead and do the left one first. We subtract 4 on both sides, subtract 4. And we have 4x is equal to 26. We divide by 4 on both sides. And we have x is equal to 26 over 4, which can be simplified into 13 over 2. Okay? And if we solve this guy, same thing, subtract 4, we have 4x is equal to negative 34. Divide 4 on both sides, and we get x is equal to negative 34 over 4, which is the same as negative 17 over 2. And the only thing I will warn you is when you have both absolute value equations and the radical equations, you need to check your answers. Plug them in and check to see if they make any sense. Because sometimes you'll end up with something that doesn't make any sense. Like, for instance, if I had a absolute value equation like this absolute value of x plus 2 is equal to negative 6, you would isolate the absolute value, subtracting 2 on both sides, and you get the absolute value of x is equal to negative 8. Now, what did we say about absolute value equations? Can they ever output negative numbers? No, right? And so this would have no solution, because no matter what number you plug in for x, it's never going to give you negative 8. It's only going to output values that are 0 or larger. And so the same thing with square root functions, or square root equations, radical equations to be specific. You need to check your answers to see if they work. Okay, so we could do that with either of these. And in both cases, these ones will be fine, but you should check your answers to see if they make any sense. Okay? All right, and then we have one more type of equation that we need to cover. Scroll to the top. And so this is called a rational equation leading to a quadratic. So what does this look like? Well, something like negative 4x plus 4 over x minus 1 over x plus 1 is equal to negative 8 over x squared minus 1. And so what you'll notice about this kind of equation is that all of our x's are on the bottom, or we have x's on the bottom, and we don't want x's on the bottom, we want x's on the top. So what you're going to do here is look for the LCD, the lowest common denominator, and you're going to multiply across by it. So we see that we have a factor of x minus 1, we have a factor of x plus 1, and over here we have x squared minus 1. But you'll notice that x squared minus 1 is a difference of squares, which factors into x plus 1 and x minus 1. So if we multiply by x squared minus 1 on both sides, we'll clear all the x's out of the denominator. And so we'll go ahead and do that. We'll multiply by x plus 1, x minus 1. And remember that you need to multiply these to everything, or to both sides, I should say. All right, and so we FOIL this one to this term and then to that term, and luckily we only have one term on the other side of the equation, so we just need to multiply it once. And so in our first FOIL, this and this will cancel, right? And so we just get negative 4x times x plus 1. And then in the second time, we have our x minus 1 back. But this time that and that will cancel, and we'll get plus 4 times x minus 1. And then here, both of these will cancel because x squared, we talked about right here, is x plus 1 and x minus 1. And so on the right side, we'll just have negative 8. Now we can FOIL this side. We'll get negative 4x squared minus 4x plus 4x minus 4 is equal to negative 8. Combine like terms, these ones will cancel, so we'll get negative 4x squared minus 4 is equal to negative 8. We add 4 to both sides, we get negative 4x squared is equal to negative 4. We divide by negative 4 on both sides, we get x squared is equal to 1. And then we square root both sides, we get x is equal to plus or minus 1. So these rational equations, we also have to check our answers, because if you notice, this says x is equal to 1 or x is equal to negative 1. But if we go back to our original equation, which I'll rewrite here, if we plug 1 or negative 1 in, what are we going to get? Well, if x is equal to 1, that means we have negative 4x over 1 minus 1. And so that is going to be negative 4. Oh, this should be a 1 as well. So negative 4 over 0. And that's undefined. So that means this solution doesn't work. And so if we plug in negative 1, you'll see that we have 4 over negative 1 plus 1. And so we'll have 4 over 0. And this is also undefined. So in fact, both of the equations that we tried, or both of the solutions that we came up with, are invalid. And so with absolute value equations, with rational equations, with radical equations, you have to check to see if your numbers make any sense. And so this is an example where we did all the algebra correctly, but unfortunately neither of the answers work. So that just means there is no solution. So for this one, after checking your work, you would write no solution. Okay? All right, see you guys in the next video.